present here. Today we want to discuss about the case study about the rigid bodies. So it will be cover the measure of first unit deformation of solids. In the class already we have discussed the stress strain relationship along with the Young's modulus, also the Poisson ratio, moment of inertia. So these are all the things we are discussed in early classes. Along with we can solve many problems in our classes. In our class, Mr. Hari Vishnu and Harris will take care of the case study about rigid bodies. If you have any queries, let it be conclude that. After that, if you have any queries, you can directly ask them. Here, shall we go with the case study?
So hi, I am going to take a case study on rigid bodies. Let me explain what is rigid bodies. A rigid body is an idealized body which does not deform easily by given applied force. This helps the engineers to calculate force, momentum, equilibrium. So let me explain with a real-time example. We all know about mobile cranes, which is used at the construction areas. By using this, the engineers should be correctly seeing whether everything supports correctly and tip over. Some of the force which are acting on this mobile cranes are force, momentum, equilibrium. In real life, all material does not deform easily slightly. But this rigid body, however, in many engineering problems, the deformation is very small compared to size of the bodies. So engineers must assume that the body is slightly rigid, makes calculation simple, fast, and accurate. This assumption is widely used in cranes, bridges, machines, and frames. Center of the rigid. In rigid body analysis, the center of gravity is the point where the entire weight of the body acts. For a crane, if the load is slightly down or up, it does not take the total load upwards. This is the main problem of the mobile cranes. Safety factors. Even every time we get something wrong. For concluding this, every calculation engineers never operate all maximum limits. They will keep slightly the density lower or something less. This keeps the load to correctly make the perfect finish. Learning outcomes. This case study, however, tells us force, momentum, equilibrium. Why equilibrium conditions are important. However, the theory of SOM is applied totally in this case study. Thank you. Continued by Harrison.
Hi, myself Harrison from SNS College of Technology, Department of Mechanical. Here I am going to talk about case study on a rigid body. As Hari stated, the rigid bodies are mostly acted in cranes to stability of the crane, to check the stability of the crane. Sum of forces equals 0 and the sum of momentums also equals 0 in rigid bodies. This helps to calculate the reaction of the force and it's help to know about the overload which is high load we can take or can pull out the material, and in engineering it will help in building areas and crane construction. By using the rigid body, it avoids some accident in in construction areas and in building areas. Here I conclude that the crane are very important in rigid bodies. The rigid bodies helps the stability of the crane and pulling power and lifting. It helps us to
the environment.
And to safely we can use the crane and buildings. It is also used in machines which to avoid the accident, and the rigid bodies is used to stabilize the crane and equal weight balance to lift the crane.
So, Harris and Vishnu explained about the case study of rigid bodies. Based on the story, we have the upcoming secondary problems like beams, cantilever, simply simple and fixed beams. So these are all the beams. It can be included with the rigid body concept. So during the problematic sessions, we have how the failures will be causes occurring to the particular area. How we want to give the remedy or precaution for the particular scenarios. If you have any doubts in this regarding the rigid bodies.
No, sir.
So already we have discussed the flexible bodies and the rigid bodies. So flexible bodies have whatever the loads or whatever the penetrations we are giving to the particular point, that can be only variation by the shape, cannot be affected the structure, but rigid body can't able to react that load because it is a rigid one, so it is a constrained one, so this is not will be stabilized. So based on the rigid body concept, we have solving the more problems for the types of beams areas. Thank you.